Hey, I'm Jay, your Moralis instructor from beautiful Finland. I got into crypto in 2020, and I've been building in the space ever since. In my free time, I enjoy running and at the gym, and in the summer, you'll definitely find me at the golf course. Now, let's get stuck in and learn about Web3. Rightio, so welcome to this week's Moralis Project, which is coined your first decentralized application. Because in this project, we'll go through all the steps to create your very first Dapp. We're going to create a Solidity smart contract using Hardhat to compile, deploy, and even verify that smart contract on a block explorer. Then we're going to use React to build this beautiful yet simple front end, and also using the Web3 UI kit to add some UI elements, and especially the UI elements that integrate well with Web3. And then the most important part is we're going to use Moralis to integrate both your smart contract and React app. You're going to be able to listen through your React app to your smart contract on different events that happen there, and also use your React app to call functions from your smart contract and then display all the information in this app. Without further ado, let's look at the build. But first, let me give a huge shout out to Bubbles, which I stumbled upon the website that this build is based on. So what it is a basic market sentiment Dapp, where the number for the different tickers identifies what the people who have voted think about the future of this coin's price. So with a lower number, there's a higher percentage of people who think the token's price will go down, and with higher numbers, there will be a higher percentage of people who have voted up and think the token's price will go up. And also, underneath these tokens, we have a little info section where you use the Moralis Web3 API to get the current US dollar price of that project and a little description. If we press link over here, we get the same thing. We get the price of link and information about link. But now let's go ahead and check out the smart contract functionality. So voting. So this means that voting is only allowed for people who call the smart contract, and you're only allowed to vote on one coin once. So you can't skew the results of a specific token. So if we try and vote down, we get a notification that you have to authenticate to vote. Okay, so we can use the connect wallet button, use MetaMask to authenticate and sign. So now we're signed in with this account, 0xC4. And now try and do this vote. Let's try and vote for link, vote down. MetaMask pops up, asks us to vote. We cast our vote. And because we're using Moralis live queries, we get an automatic response changing the percentage of people who have voted on this coin. So now there's a larger percentage of people who have voted down on this coin than up on this coin. So now if we try and vote again, try and vote more down, we get an execution reverted. You have already voted on this coin. Same thing, if we go and vote for ETH, we can vote up, accept our MetaMask transaction. And now that the transaction went through, our percentage of people thinking that ETH coin will go up in the future has gone up to 86%, giving you a nice little idea of what people in the market think on the future of different coins. And to convince you even further, I'm here on Polygon Scan where our smart contract is deployed, and every time we make a vote, a smart contract event is emitted called ticker updated. So here we see our account 0xC4 updated the ETH token to 6 upvotes and 1 downvote, making that percentage 86%. And then we also voted on link, where 0xC4C made the vote, and now it has 4 votes up and 5 votes down, making that 44%. So you see, this gives a whole lot of transparency, as anyone can go search the block explorer and see what the current status of voting is and who has voted. And that's not all. We have all these smart contracts events automatically synced to our Moralis database. So here you see the same votes, Link and Ethereum, the current votes down over here, and the current votes up over here, and the voters as well. And this is what we're using to pull to our app. If you're excited for this build, stay stuck in. And remember, if you finish the build, you get a cool NFT as a reward. Also, be sure to check out the Moralis Academy, where you can follow this lesson in nicely structured lessons. You might even find some other cool tutorials you might want to take part in. All right, now let's go. All right, let's get into the build. So, as always, I provided a starter repository for you guys called First Dapp Starter, and you can clone it from the link in the description below. It'll have everything you need for this project. And to start us off, let's build our smart contract using Hardhat. So you want to cd into the smart contract folder, like so. And the starter repository doesn't have Hardhat installed, so you'll have to install it. Go ahead and do npm id and Hardhat. Let that install for you. And you'll see that in our smart contract folder, we don't have anything yet, but we can initialize a new Hardhat project by running npx Hardhat. we'll want to create a basic sample project, press enter, 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 enter. Wait for this to install as well. The project is created, and you'll also see that your smart contract folder is populated with everything we need to get going. But first, let's install a few dependencies we'll also need. So let's do npm id.env and npm id at nomic labs / hardhat etherscan. And now you have everything you need for this project, and we can go ahead and open this contracts folder, and we have this file called greeter.sol, a Solidity starter file. Of course, we want to create our own smart contract to analyze market sentiment, so we can delete all this. We're not making a greeter smarter contract, and we can rename our Solidity file, rename it to market sentiment.sol. And to start our smart contract off, we always have to define a license and the version of Solidity we're going to use. So we're going to use the MIT license and Solidity 0.8.7 and above. And then we can create our contract by running contract, market, sentiment, and squiggly brackets. And now inside these squiggly brackets, we can write our Solidity code to let anyone with a crypto wallet address interact with our smart contract and vote on their sentiment of different cryptocurrencies. So first of all, at the start of the contract, we'll want to define a few variables. We'll define the address of the owner of the smart contract. This will be the one who's able to add new tickers or cryptocurrencies to this smart contract. And of course, we'll keep track of all the tickers or cryptocurrencies that have been set by the owner. So an array of strings over here. And then of course, we create a constructor function. So this is a function that is run at the creation of the smart contract. We won't define any parameters. And all this constructor is doing is whoever deploys this smart contract, so as the message.sender, will become the owner of this smart contract. Let's save this. Now here under our constructor, let's define a struct, which essentially is just a definition of any ticker that the owner creates. So any cryptocurrency that is added to the smart contract will follow this structure. It will have a Boolean that is set to true if the ticker exists. So say we add Bitcoin, this Boolean will be true. Then it'll have a uint256, which is essentially a number declaring how many votes of up it has received, and similarly uint256 for down, so how many wallets have voted down for this. And of course, it'll have a mapping keeping track of all the voters for this ticker. So every address, these are cryptocurrency wallet addresses, are mapped to a Boolean. So anytime anyone votes, we'll set that cryptocurrency wallet address to true. So they've already voted for that specific ticker and they can't vote for it again. So you only have one chance to vote for your sentiment on a specific cryptocurrency. And when this is initially set, everyone's address is false, so anyone can vote on that cryptocurrency. Now next, for the sake of transparency and for Moralis to be able to listen to any events that happen on this smart contract, we'll create this event called ticker updated. So when anyone updates their vote on any ticker that the smart contract has, we'll emit this event called ticker updated. It will give us the current number of votes up and down, the voter who just voted, and the ticker they voted on. So this will be very useful for us when we're using Moralis to listen to the smart contract and get the current status of votes to our Moralis database that we can then present in our app. And finally, before we go ahead and create our first functions, let's create one more mapping that takes a string and maps it to our ticker structs. So write ticker over here, and this will be a private mapping for this smart contract, and we'll call it tickers. So what this does, it takes any string and maps it to a ticker struct. Of course, if this ticker isn't created, the exist Boolean will be false, but anytime we add a new ticker to the smart contract, we'll set this Boolean to true. So say we create a ticker with string BTC, we set the Boolean to true, and our tickers mapping will return us this struct for BTC, letting us know who have voted and the direction they have voted. And leading on from this, we can now create that function to add tickers. And this will of course be a function that is only callable by the owner of this smart contract. And let's see how we do that. So we create this function called add ticker. It takes as a parameter a string that we set when we call this function, and we'll call it _ticker. And it's a public function, which means it is callable by any user. But at the start of this function, we'll create a require statement. And what we require is that the message.sender is equal to the owner of the smart contract. And if it's not, we'll give an error that only the owner can create tickers. Now in this function itself, we want to create a new string in this mapping of tickers, with the string being equal to the ticker that was set as the parameter to the addTicker function, and then it'll create a ticker struct for us with details for that ticker, preset to 0, of course, for the votes, and we'll set the exists boolean to true. So now let's go ahead and create this new ticker. So from the tickers mapping, we get this string that we set in the call of the function, and we get a temporary ticker storage, which we can start setting the variables for. So new ticker exists will now equal to true. And now we essentially have stored in our contract the ticker that people can vote on. Of course, we can also add it to our ticker array, so we can have an array of the different tickers we have set. So that is simply just a push, like in JavaScript, tickers array dot push, and we push again the parameter that was set in the call of the function, so ticker, like so. And that is our first function complete. How cool is that? So now we have a smart contract where you can add a ticker if you're the owner of the smart contract, which has this struct. And from here on out, we want to create a function where we can vote. So on any created ticker, we want to be able to increment the up variable or the down variable by 1 in relation to what we believe that cryptocurrency is going to do. And then of course, we'll set our voting status to true so we can not go back and change our opinion anymore, nor vote multiple times, skewing the results. But now let's go ahead and create another function underneath our addTicker function and call this vote. So this is our voting functionality where we have to pass two parameters, the ticker again that we want to vote on, and boolean, which will refer to your vote. If we set the boolean to true, we'll set that to mean that we're voting up, and if we set the boolean to false, we'll make that mean that we're voting down. But again, starting off with the require statements, we'll have to require two things. First, let's make sure that the ticker is actually present in the mapping that we have set. In this tickers mapping, we search for that ticker that we call in the parameter, and as long as the boolean exists is set to true, we can vote on it. Otherwise, we'll get an error saying can't vote on this coin. Next, let's write another require statement. Let's make sure that the mapping inside this ticker struct for the coin we are looking at, so whatever ticker we've set, the mapping inside here will make sure that the address that is making this call, so the message sender, has not voted on this coin already. If they have, we'll create an error. So this will give us a true or false. If it gives us false, which we want it to be, we use the exclamation mark operator to convert it to true and allow us to proceed to the function. But if it is already set to true, we won't allow this function to be called because the user has already voted for that coin. But now for the functionality of this function. We can start in a similar fashion as we did with the addTicker functionality. So create a temporary ticker struct for the ticker we are after. So in this variable t, we have a ticker struct that represents from our tickers mapping the ticker that we have called in our function call. Now we can set our t.voters, which was the mapping of people who have voted for that ticker. And for our message sender, which is our address, we will set that to true. So now anytime this user with this address that the message sender has tries to call this vote functionality again for the same ticker, they'll be caught in this require statement. So they can only call this function once. Then we also want to set the vote, whether it's up or down. So we have to look at our boolean vote over here. If the vote is true, like so, we can set our t.up to increment by 1. But if it's false, we'll do t.down will be incremented by 1. So this way we store in our ticker struct for the coin in question. So say we call BTC, that this new address has voted, they can't vote anymore, and we've incremented the up and down votes respectively, which one ever they voted on. So this way we have voted on this coin. And finally, because we want to be able to notice with Moralis when a new vote has been made, we can call this event, this ticker updated event, and emit it. So underneath this if-else statement, we can call the emit ticker updated like so, where we get the current number of votes up, current number of votes down because they have already been set, the message sender, who was the person who made its latest vote call, and which ticker did they vote on, BTC, ETH, Link, or whatever they have called. So now we're basically ready. We can add one more function. So if anyone in the public wants to get the votes for any ticker at any time, we can add a function for that. So get the votes for any ticker will be the functionality of this last function. Rightio, so let's scroll down a little bit and add our function over here. So the function's name will be get votes. It'll also take the ticker as parameter, so we want to get the votes for a specific ticker. And this function is a public view function, and it returns something. So we have to provide what it will return. So it'll return two uints, an up and a down. So essentially, for any ticker, how many votes has it got up and how many votes has it gone down? And then for the functionality, it is pretty much the same as what we've done already. So I'll just paste it in over here like so. So again, we require that the ticker that we're calling actually exists. Otherwise, we'll say that no such ticker defined. And then we'll get that t from our tickers mapping and return just the up variable and the down variable, which are both uint256s. And that has your smart contract finish for voting on specific tickers that the owner has set for this smart contract. And next thing we can do is use Hardhat to compile this contract and then deploy it to any network we want. We'll use the Polygon testnet Mumbai in this example, and then we'll also verify the smart contract. So you can actually call different functions from the smart contract on the Mumbai block explorer. So make sure you save this contract, and let's actually change the contract name to capital M and capital S like so, and save. Now from here, you can move on to the scripts folder where you have a sample scripts.js file. We can rename this to deploy market sentiment.js like so. And there's a lot of comments over here, so we can remove these to see better. And over here, of course, you remember that we had the greeter.sol contract over here at the start, and that's why we have greeter all over here. So we can change all the greeters. Let's make this case sensitive and find all the greeter words and change these to market sentiment. Let's change all of them and then do the same for just the lowercase greeters and change those to lowercase market sentiments like so. So now, one more thing, because our market sentiment deploy, we have passed some parameters. These are the parameters you'd pass if the constructor took any parameters, but in our case, our constructor did not take any parameters, so we can remove this over here. And now you have this deploy market sentiment JS script ready to rock and roll. And with this done, we can then open up this hardhat.config.js file. And at the start over here, start off by requiring Nomic Labs Hardhat Etherscan, which will allow us to verify our contract eventually, and also const.env will be equal to require.env. So we'll have our environment variables in a .env file, and we'll also configure our .env file at the start over here, config like so. So this means we can go ahead and create our .env file over here, go over here, do .env, create that file, and in here, we'll create a couple of environment variables. We'll create the endpoint to our Mumbai network node so we can push our smart contract to the network. Then we'll also need a crypto wallet's private key, so that will be the owner who deploys the contract, and then also a Polygon scan API key, which will allow us to verify our contract. So let's go get those now. Starting off, find yourself at Polygon Scan, or if you want to use a Ethereum test network like Rinkeby, you'll go to etherscan.com and go ahead and sign in at the top right. And after you sign in, you'll come to your home page where you get this API keys tab, and you can go ahead and create a new API key. I already have one. I'll delete this API key token before this video comes out, so you have to go make your own one. You can't just use this, but you'll copy this and go back to your env file and go ahead and give it a name. API_key will be equal to single quotes and put your API key in there. Next, we'll need our node endpoint, and for that, you'll go to moralis.io. Moralis.io, go ahead and log in over at the top right, and it will take you to your admin dashboard where you have your servers. We won't need the server yet, although we will create one later on in the video when we create our React app. But now go over here to Speedy Nodes and choose the network you want to connect to. Because we used Polygon, we'll go to Polygon endpoints, and we'll need the Mumbai Speedy Nodes from over here. This is the endpoint we will need to call to talk to the network, and go back to Visual Studio Code and give a variable name, say Polygon Mumbai will be equal to single quotes and your Speedy Nodes Moralis endpoint. And finally, you'll need your crypto wallet's private key. So let's do private underscore key. I won't add one here just because it's good practices to never give your private keys out, even if it is a sample wallet. But how you'd get it is go to your browser, and where you have MetaMask, open it up, press these three dots, account details, and then you can export your private key from over here. This is your public key, but you'll need your private key. So that is where you get it, and then paste it over into your private key variable over here. Let's save this and go back to our hardhat.config.js file. It seems like at the start we misspelled .env over here, so let's change that to a .env like so. Save that. And now you can find your way to the bottom of the page over here where we have module exports. First of all, Solidity version is 0.8.7. That is what we defined in our smart contract. Then let's create another object called networks. So it'll be an object, and within this object, we'll define Mumbai, which is the network you're going to be using. If you're going to be using Rinkeby, you'll define Rinkeby. And then within this object, we'll have the URL, which we get from process.env, and now whatever variable we set in the .env file. So it'll be polygon underscore Mumbai. And then for the accounts, will be an array, and the same thing, process.env, and over here, the variable private underscore key. Let's remove this empty line and add a comma over here. And then outside of the networks object, we'll create one more object, and it will be called EtherScan, and this will allow us to verify our smart contract. And here we'll provide our API key, which we set in process.env as API underscore key, and then save this. But you know what? That's almost 20 minutes of coding our smart contract and setting up Hardhat. But now we should be able to start compiling our smart contract and deploying it and verifying it if we've done everything correctly. Hopefully you're excited and hopefully this works. So let's start by going into our console over here and typing npx hardhat clean and then npx hardhat compile. And look at that, compiled one Solidity file successfully because we had everything set up right in our smart contract and our deploy market sentiment JS file. Now for the real bit. We're gonna actually deploy this smart contract on the Polygon Mumbai test network. So how we do that is go ahead and type npx hardhat run scripts deploy market sentiment.js space, couple lines, network, and Mumbai. Now press enter, and our market sentiment smart contract has just been deployed to this address. And now if we go check out Polygon Scan, and especially the testnet Mumbai, we should be able to see our smart contract. Let's get this address from over here, copy it, head over to Polygon Scan. So here on Polygon Scan, make sure you change to the testnet. So now we're on the Mumbai scan, and let's put our smart contract in here like so and search for it. And wow, look at that, 1 minute ago, contract creation. Our smart contract is live on the Polygon Mumbai testnet. If we look at our contract, we only have the bytecode right now because we haven't verified our smart contract, but we can do that also in our VS Code terminal. So going back in here, let's go ahead and type one last command, which will be npx hardhat verify, then our smart contract, and again, a couple lines, network and Mumbai. And that ran for a while, but successfully verified contract market sentiment on EtherScan, but it actually means Polygon Scan. If we go back and check out our smart contract, we're here on Polygon Scan. If we go ahead and refresh the page and look at the contract, we have a verified green tick contract where we have the market sentiment contract we wrote just in this tutorial. How cool is that? And the coolest part, we have the read contract functionality and the write contract functionality. So the owner of the smart contract is this address that I showed you at the start. Over here are 0xF03, 0xF03. And of course, we don't have any tickers yet. So we can go ahead and write in our smart contract to add a ticker. Let's first show you that if we try use another account, let's go to account 3 over here, which isn't the smart contract owner, and try and write a ticker, say BTC. Make sure you connect to your Web3 using MetaMask. Okay, and this is not the contract owner, so if we try and write this, it shows that we will get an error if we try and write on this contract. So let's reject that and go ahead and change our account. So I just went ahead and reloaded the page, connect to Web3, MetaMask, okay. And we are on the smart contract owner right now. And if we try and add a ticker, BTC, we write that, we won't get an error this time, and we can add this ticker if we confirm. Add ticker functionality is pending, and we have added that ticker to this smart contract. Now, if we go ahead and read the contract, we can try and get the ticker array from the ticker array, say the first index, query that. That is BTC. We haven't added anything else, so in the array there shouldn't be anything else. Returned error like so. And we can also get the votes currently for BTC. So if we query this, the votes for up are 0 and the votes for down are 0. We can go ahead and make our vote. We are very bullish on BTC, so we give the ticker BTC and we vote true like so. Write that. MetaMask pops up. Let's confirm that. We're waiting for our vote function to go through. That went through. Let me just show you if I tried and vote again to add another vote, right? It again shows us that we'll get an error if we try and do that because we don't pass the require statement because we've already voted on this coin once. So reject that. And we go ahead and read our contract. So we'll try and query BTC once more. And look at that, we have one vote up. And in the events, look at this, 43 seconds ago, there was one vote. So now I've changed all of these to readable formats. So we see our total upvotes for BTC is 1, our total downvotes is 0, and the latest voter was us, in fact, ourselves. So how cool is that? We've actually made a smart contract where you can vote on tickers that the smart contract owner has actually set on the smart contract. We can actually go ahead and add a couple tickers here as well. So let's write contract, let's add ETH, right? So now ETH's created, and let's go ahead and add a link as well, write that. So now link's created, I just went through that very quickly. Let's make a vote for ETH. Let's vote for false, so we're not very bullish on ETH. And then the same thing for link, but let's vote true for that. And let's just go check that everything worked properly. So we go look at our ticker, let's say BTC, query that, one vote up, ETH, query that, one vote down, and link, query that, one vote up. And then we can change accounts to increment these votes even further. So rightio, that is how we make a smart contract with Hardhat, compile it, deploy it, and even verify it. And then we can interact with it in the Block Explorer. But next, we want to create that React app so we can interact with this smart contract through a nice web interface and make those nice bubbles showing us the current market sentiment for different tokens when a load of people start voting on this smart contract. Let's get into creating that React app. So when you return to your IDE, we got a lot of things going on, but we can close most of this because we've already deployed our smart contract, so we don't need these anymore. And our console, we can clear it, and then we'll CD back one step to go to our first Dapp starter folder like so. So we're in this folder, and it is a folder created with Create React App, so you can run yarn to get all the dependencies we'll need. And then if we look at the source folder over here, you see that we have this index.js file showing it is a React app that is wrapped around the Moralis provider. Later on in the video, we'll provide an app ID and server URL to get Web3 elements integrated. But everything is running in the app component. So if we look at app.js, it is an empty file with nothing in it. So if we go and check yarn start, we should get just an empty web page running on localhost 3000. And that is exactly what we get. It's a dark theme I've set for you guys to get us going. But just to make sure everything is working before we go ahead and start working on this, let's go ahead and go into split screen mode. And here in our app component, let's create a simple div and fill it with, say, hello. And it is very dark, but over here you see that the hello pops up in here. So let's go ahead and start creating this one-page simple app by adding a header. For the header, we'll need to import two components. We'll want the Moralis logo in the top left, and then we'll want a Web3 authentication mechanism in the top right we'll bring in from Web3 UI Kit. So let's bring in the imports first. So we'll bring the connect button from Web3 UI Kit, and then in your folder you have a images folder with a moralis.png, which we'll call logo. Then we can call this div with a class name equal to header. And I'll just show you quickly that in our file directory, we have app.css where we have all the CSS styling for this project. So we won't go through it now. If you're really interested in it, you can go check out where the styling is coming from, but it is just simple CSS that you can wrap your head around. Then after this, let us create another div. And for this div, we'll give a class name of equal to logo. And within this div, we'll put our image logo that we brought in over here at the start. Let's just open this up a little bit so you can see everything properly. So we'll add an image and the source will be equal to the logo. The logo. And well, we can just say logo. Like so. And then we can also add a little sentiment text to make it look dapper. Save that. Seems like our Moralis logo is massive, so let's just add a height of 50 pixels for that. That should close that. We misspelled height. And now that is beautifully over there, Moralis sentiment. And the connect button is even easier. You just add connect button like so. And we have a connect wallet button over here. Our header is finished. How quick and easy was that? I'm telling you, this is a very basic, simple project. Perfect for your first app. Now underneath our header, we can add a little instructions title by adding another div, giving it a class name equal to instructions. And then as the text, we'll just put, where do you think these tokens are going? Up or down? Simple as that. And now we have a nice header and then this instructions title. And under this, we can add our different token bubbles and the choice of choosing up or down, and then a info box as well later on. But now going ahead and creating those coin bubbles, what we'll do is we'll create components for them themselves. So we'll add a coin over here like so, and it'll take a few props. So we'll set the percentage to be equal to something. We'll set setting the percentage to something, and then we'll set the token. And the token first one will be just BTC like so. Setting the percentage, set BTC, and the percentage will be BTC. So these are state variables that we have to set. We are bringing use state from React, so we can just create that state variable over here. Const square brackets BTC and set BTC equals use state, and we can set it to be 50 to start off. So now we are creating this coins component, and we're passing it as props the percentage that it is at this current moment. We'll use the Moralis database to actually get the percentage later on, but now we'll just set it to 50, and we can also change the percentage, and we're also passing the name of the token we're setting. Just make sure you also import the coin component from ./components/coin like so. So if we save that and go check out our file structure, we have this components folder with a coin.js file, which is empty. And if we add another hello here, div, and add a hello, you see our hello pops in here because it is the coin component rendered in our app.js component. So let's jump into our coin component and start by passing our props over here. So what do we have? Percentage, set percentage, and then lowercase token. Save that. Now with these props brought in, we can create our first rendering div. So we call it class name equals token. And you guessed it, inside we just render the token name that was passed as props. So now we get BTC over here. How cool is that? After that, we can create our circle. So let's create another div, give it a class name of equal to circle. inside of which we'll have another div, this one called class name wave. This will give us that nice wave effect that you saw at the start of the video. Let's just put these on the same line. And then over here, we'll have our last element, which is a class name of equal to percentage. And in that, you guessed it, we'll have our percentage prop go in. So if we save that, it doesn't look like much yet, but we have our 50 over here. Make sure to go back to your app.js component and wrap all your coins, we'll add some more later, inside a div. And we'll call this div a class name of list. Class name equals list. This will just make everything look very nice. Format this document nicely. So now they're aligned very nicely. We can move on from the app.js back to the coin.js file. And now you're probably wondering how to get that nice wave element over here. And to do that, let me just first paste it in here. So we'll provide some inline styling, a margin of top, which will be 100 minus whatever the percentage is, giving us the right height for the wave. And then a box shadow, we preset the color to green over here. We'll soon make a calculation to determine whether it's green or red, and then a background color of green as well. So if we save that, look at that, we have that wave floating around over there. Again, it's all in the CSS files. If you're really curious on how to go about creating the CSS animation, it is here. It is a spin animation that just rotates around, and you get that nice element because we have border radiuses of various percentages over here. But back into our coin.js file, we also have to provide this box shadow style. Copy that over here to the circle div. So we do style equals a couple of squiggly brackets and add that in there. I guess we have an extra double quotation mark over there. And now it looks beautiful like so. But because we want to automatically generate the color, we have to make a state variable over here that calculates whether the percentage is 50 or above or under, and that way sets these colors to green or red. So let's do that next. At the start here, we can add our state variable called color, and then create a use effect. We bring that as well in from React, and this will set our color to a nice orange. This is a nice orange color if the percentage is less than 50, but if it is over 50, we will get this nice green color we already have. All we have to do now is just set color over here, color, and then in our template literal over here, we just have to make sure that we put a $, our squiggly brackets, and then our color. And we can copy that and paste it over in here as well in the circle div, like so. Save that. And now that is beautiful. If we go to our app.js file and change our BTC percentage to 38, our wave does not only drop, but it also changes to a red color. We can change it to 80 over here, save that, and now it goes up. And this will be very cool when we have live queries from the Moralis database. When people actually make a call to the smart contract to vote, this will automatically render to the correct height based on the ratio of current votes. One last thing we can add, after our percentage, we can add a percentage sign like so. Just makes it look ever so much nicer. Moving on, we can go ahead and create those buttons over here. So an up button and a down button. So when we vote, our percentage will change because now we have more votes for up or more votes for down. So over here below our second to last div, we'll create a new div and we'll give it a class name of equal to votes. And in here, let's just make this a bit nicer like so, and add over here, we will need to add a button from the Web3 UI kit. So over at the top, we go ahead and import button, it's a capital B, from Web3 UI kit, like so. And then we can go ahead and add the button in here, like so. So now we have a button. We haven't determined our on-click event yet, but the text will be up. It'll be a primary color and the type will be button. If we save that, now we have our up button over here. We can add another button for our down option, adding it over here. Let's just make this all look neat. All right, so now everything looks neat and tidy. So this is basically a similar button, but just the theme is colored and we set the color to red. Save that. And now we have a up and down button. The last thing we have to do is use our set percentage over here to increment our percentage up or down depending on which button you press. Meaning that here in the up button, we can set pers to equal pers plus 1, and then the exact same thing in our down button, but we'll do -1 instead of +1. And now we should have a working prototype ready over here. But to make the page interactive, we have to initialize Moralis. So head back to your Moralis admin dashboard and create a new server. We'll create a testnet server. Let's just call it My First Dapp. Select the region closest to you and choose Polygon Mumbai over here, add instance. And now, My First Dapp over here, we can go ahead and get the server URL and application ID, copy the server URL first, and in your file directory, find the index.js file, and in your server URL, paste that server URL, and same thing for your app ID, copy that from there, and paste it in here. And now, we'll come and use our Moralis server a bit later, but now our React app should be ready to rock. If we refresh the page and start pressing up, look at that. It is very interactive. Okay, I speeded up the video to get to 50, and see if we go down one more, it automatically changes our color to 49. How cool is that? So now we have a working sentiment bubble. Although it's only manually adjusted on this page, we can soon go on and attach it to our smart contract. But before we do that, let's just finish out the UI elements. So add a info button over here that pops up a modal for us, which shows us some information about this token, BTC, and also the current price for this token using the Moralis Web3 API. And then of course we can add some other tokens like ETH and Link that we already added to the smart contract when we were working on Polygon Scan. So adding that modal, we want to go back to our app.js file and make sure that from Web3 UI Kit, we also import modal like so. And then at very bottom of the page over here, let's just add a modal. And you notice that it takes a few parameters. We set isVisible to a visible state, and then when the close button is pressed, we set visible to false. And then the title of our modal is set to a state variable called modal token. So we have to set those few state variables, modal token and visible. Let's do that over here under our BTC like so. So now we have a initial state of visible false, and then our modal token is not set at the start. And what we actually want to do is that we want to create in our coin component a button which changes this modal token. So we pass set modal token to the coin component as a prop as well, and setting the visibility as we also want to set it visible as the button is pressed. Now, rather than me just rambling on, let me show you what we're going to do. So let's put this coin component into a nicer format like so, and then pass the props that I just told you. So set modal token and set visible. Now save that and go back to our coin.js component. And in here, pass those props, set modal token and set visible with a capital V, of course. Save that, and now create one more button at the bottom over here. So we have our votes for up and down, but let's create another div called votes, but only have a info button in there, like so. So essentially we create another div so it goes below these buttons, and then on click of this button, we set the modal token to the coin that is selected, and we set the modal to true so we see it. And the text is just info. So if we just save this and see what happens, you see we get that nice beautiful info button, and it should be functional. So if we refresh the page and press it, we get this nice BTC info modal like so. And a cool thing we can do now is let's try and add a couple another tokens, ETH and Link, and we should get the same functionality for all of them. So head back to your app.js file and get this coin component from over here, and let's just copy that a couple of times and just change these to ETH and Link like so. So now we've added the respective state variables ETH and Link over here, so we have to also bring them in at the start over here like so. And now if we save the page, you already see ETH pop up over here, but if we go in full screen mode, we get all our different coins over here, BTC, ETH, and Link. If we refresh to get the functionality working, if we press info, we get this one to open up ETH. Same thing for this should open Link, and then this should open BTC. Now, last thing we have to do in this modal is use the Web3 Moralis API to get the current token price for BTC, ETH, and Link. And then I have a file in our repository where I have a little bit of info about each of these coins, so we can just present that in this modal as well to fill it up and make it look beautiful. So maybe we get going by adding that text about each coin, which is the simplest bit. So let's go split screen mode again. And over here in our file directory, I'll show you we have this file called about.js. And all this has is an array of tokens. So we have our BTC, ETH, and Link. And then we have the address. For Bitcoin, we have wrapped Bitcoin. And for Ethereum, we have wrapped Ethereum, because that will help us get the token price, as we don't have Bitcoin on the Ethereum chain. And Ethereum is the native token for the Ethereum chain. So we'll just use the wrapped versions, but for Chainlink, we have the actual address for the Chainlink token. And then we have a little bit of an info text that's copied from CoinMarketCap stored in the about key. So what we can do is we can import this whole about array into our app.js file. And we do that over here by importing about in squiggly brackets from ./about. It is as easy as that. And now we can use this about array to populate our modals with the correct text. And how we do that is we scroll down to the bottom where we have our modal. And inside our modal, we create a div. Let's open this up full screen for a while so you see what's going on. And essentially what this div is, we have first a span that just says about, and the color is set to white just to make it pop out. And then we have underneath that another div. As long as we do have a modal token, we'll search the abouts array and find the index of our modal token and present the about text for that. It seems like we used abouts, not about, so let's just change that to abouts over here. And now if we save this, go to our page, you see our Bitcoin is already populated. Bitcoin is a decentralized cryptocurrency originally described in a 2008 white paper, etc. And the beautiful thing is, when we go to Ethereum, we get the Ethereum text, and when we go to Link, page crashes, but that's good. We know something's wrong. If we go back, it seems like we have a lowercase link. So let's just change that to a capital Link in our coin component over here. Link like so. So they have to match exactly what we have on our about.js file. So over here, refresh. If we scroll down to Link and press info, now we get the link description. Now above this about, let's do our price. And you won't believe how simple this is with Moralis. So let's close our modal over here, go up over here and import the Moralis Web3 API from React Moralis. Save that. Then let's create a state variable to keep track of the price to present in the modal. Let's call it modal price, like so. So now we have a state variable to store our price in. And then to call our Web3 API, we have to get Web3 API from Moralis Web3 API. Now, all we have to do is create a use effect that runs every time this modal token changes. So every time we open a info box for a different token, and then gets our token price for that token. So let's create that over here. Boom shakalaka. So now we have a use effect which runs every time the modal token changes. And what we want to create in here is an asynchronous function that fetches the token price using our Web3 API. Let me just paste it in here like so. Let's open this full screen so you see what's going on. So we have this asynchronous function called fetch token price. The only option we have to set is the address of the token, because we're using Ethereum network's tokens. And what token address we're getting is the modal token that we have opened, so BTC, ETH, or Link, and we're using our abouts array to get the address for that token. And then we get this price object by awaiting our Web3 API using the token property to get the token price using our options, which is the address of the token. You can console log this price, but this gives you an object with one of the keys being US dollar price, 2 decimal points using 2 fixed, and set our modal price to that. And one last thing, because we're only creating this asynchronous function in this use effect, we also have to call it. So let's fetch token price in here, but we only do this if we have a modal token. If we don't have a modal token, we won't go ahead and run our Web3 API. So if we save that now, we should have a working token price, but we're not presenting our modal price anywhere. So let's just go ahead to the bottom of the page where we have our modal. Let's add a div above here, which will present our price for each token. So simple as that, one div with a span of color white and saying price, and then next to it we'll just have the modal price state variable, which changes every time we open a new modal, and then a $sign afterwards. If we save that and go check out our page, now here let's try and open BTC, and it runs and gets our Bitcoin price, which is about $39,000 at the time of filming this video, and the same thing for Ethereum, $2,900, and for Link it should be somewhere around $11-12. Yep, $11.95. Hopefully these numbers go up in the future, but our Web3 API is working, which is the most important thing, and you have live token prices for your coins as well. And now, last thing we have to do is connect our Dapp to the smart contract, and we'll do this by using Moralis. First, to sync events that happen on the smart contract, store them in our Moralis database, and then get the current votes to our app, calculate the ratio of votes up and down, and present them in these bubbles. Hopefully you're excited. Let's get stuck in. To be able to do this, let's first open this browser full screen and go to our admin dashboard. In our My First Dapp server, let's view the details and go to our sync events. So we want to create a new sync event to sync all the events that our smart contract emits of new votes being made on the smart contract. So let's add a new sync event, sync and watch contract events. Of course, we're on the Polygon Mumbai testnet, which is perfect. Description, new vote. And we'll want to sync our historical options as well, because we already made 3 votes at the start of the video. Now our topic will be the event name with all the variable types that it emits. So let's go to our contract on Polygon Scan over here, and we have our ticker updated event over here. So we can copy that. See how good this is that we have our verified smart contract on Polygon Scan. Go back to our sync event and paste it in here like so. So we have our event name and only the variable type. So remember to remove the variable names as well. So we have UN256, UN256, address and string. Then for the application binary interface, this is also presented to us on Polygon Scan for verified contracts. So let's go to our contract on Polygon Scan over here and scroll to the bottom where we have our contract API. We don't have to copy all of it. All you have to do is find this ticker updated event and copy that. So it goes from here all the way up to here. Copy that, head back to your admin dashboard, paste that into your API field over here, scroll down, then we need to get the contract address, get that from Polygon Scan, copy that from over there, paste it in there. We won't have any filters for this, and then give a table name. We can say votes and then confirm. And now our Moralis server is syncing any events that have happened on the blockchain into our database, and it constantly keeps looking at our smart contract to see if any new events happen, and then we'll update our database accordingly. So let's go check out our database first. Go over here, press dashboard, and you have this votes class. It may take a while for the historic sync events to be recorded, but let's refresh the page. And now we see that our votes are up. So we see that we have 3 votes that have occurred, and that's what we did at the start when we were playing around with Polygon Scan. We have 1 for BTC, 1 for ETH, and 1 for Link. And we see the voter address, and we see what the voting status at that point was. So for BTC, we voted up, so that was incremented by 1. ETH, we voted down, that was incremented by 1. And Link, we voted up, so that was incremented by 1. Now the cool thing is, if we make a new vote with a different account, this table will be updated with the new vote for whichever ticker it was voted on and the new counts for up and down. So let's try and do that. Let's go to Polygon Scan, and here on our contract page, let's go and write our contract. Connect to Web3 first, but this time with a different account that we made the votes earlier. Like so. So now 0x4c is connected to Polygon Scan. And let's go ahead and make a vote for, say, Ethereum. And although our first voter said down for Ethereum, let's say true for this voter. True, let's write that. MetaMask pops up, lets us vote, confirm. Let's wait for that to go through. Our vote successfully went through. And now if we go check out our Moralis database without doing anything and refresh our votes class, you see suddenly we have 4 votes rather than the 3 we had prior. And the latest vote is over here. We get the blocks timestamp when it was voted, and we get the current vote status. So Before, for ETH, we had 1 vote down and 0 votes up. But now, with the latest voter, 0x4c, we have 1 vote up and 1 vote down. How cool is that? So now, what we can do is use our React app to pull data from this votes class in our Moralis database to get the current status of votes and present the correct percentages in these bubbles rather than preset percentages that we have currently. So let's go ahead and do that now. Put this in split screen mode and head over to our repository, the app.js file, where in addition to use Moralis Web3 API, we'll also bring in use Moralis, which is basic Moralis functionality, and we can destruct Moralis and is initialized from use Moralis. So this just means that we can use different functionality from our Moralis, and we make sure that the Moralis provider initializes Moralis before we use any of this functionality. And now let's create our function to get a ratio of votes for any token we requested. So let's create an asynchronous function called getRatio, and it takes as parameters the ticker and set percentage. So we can set the current percentage of any of our bubbles. And then the functionality will go inside of here. Now, first of all, we extend the votes class from our Moralis database and make a query to this votes class. Then we make sure that the ticker key in our votes class is equal to the tick we set when calling the getRatio function, and we set the query to be in descending order of created at functionality. This will allow us to get the first element, so the most recently created vote. Following that, we can get the number of votes up and number of votes down by looking at our results, objects attributes, and getting the up key and the down key and turning them into numbers. So now we have the number of votes up and number of votes down, and then calculating the ratio is simple. You just calculate the number of votes up, divide that by the total number of votes and multiply by 100, and then we also round to full numbers, and then we can use the set percentage to set our new percentage to whatever this ratio is, like so. So now we have a function. As long as we call a ticker and one of these setting of state variables, we can get the current percentage of votes for any of our tickers. So what we have to do is create a use effect that is triggered every time Moralis is initialized to go get from our Moralis database the current number of votes. Without further ado, let's just create that use effect below over here. Simple as that. So every time is initialized state changes. So when this app runs for the first time, we check if we have the initialized state, and then we get the ratio for BTC, set the Bitcoin percentage. We do the same for Ethereum, set the Ethereum percentage, and we do the same for Link and set the Link percentage. Now, if we save this, we should get a percentage of 100 for Link and Bitcoin and a percentage of 50 for Ethereum. So let's try and save that, go to our app, and look at that. It seemed like it worked. We open this full screen, and Bitcoin is a full 100%, Ethereum is 50%, and Link is 100%. How sweet is that? That's data from the blockchain that is stored in our Moralis database, now presented in our Dapp. What we can do still is create a live query to make sure that whenever something is updated on our database, our React app responds to that immediately. So let's create that live query and show you how it works. Let's go split screen mode. And inside our use effect, where we check if it's initialized, let's also create an asynchronous function called createLiveQuery. So what we're doing is we're making a new Moralis query to the votes class, and we're creating a subscription by doing await query.subscribe. And now, by calling subscription on and using the update command, we always get an object when any of our rows in our Moralis database here in the votes class is updated. So we get that object or that row, and then in here we can write the logic where we simply just check that if the object's ticker is Link, we get the ratio. We do the same getRatio functionality for Link, same for ETH, we do the getRatio for ETH, and if it's BTC, we get the ratio for BTC. And then because we are, again, just creating that live query, we also have to call that function createLiveQuery inside our use effect. And now we should have live queries set up. So at first initialization, we just get the current status of our Moralis database. And after that, we're constantly live querying our Moralis database to see if anyone makes votes on our smart contract and our votes class is updated, then we get the new ratio automatically for our React app. Let's see how this works. So if we save this and open up our database side by side with our app, like so. So it's a bit squished up, but you get the point. We have this row for our BTC vote, and say we just updated the BTC downvotes to 3. Look, our React app automatically updates to 25% because now we have 1 upvote and 3 downvotes, resulting in a 25% sentiment on the Bitcoin token to be going up. Same thing we can do. So let's go for, say, link. Let's do a 2 over here. Now it changes to 33% because we have 1 vote up and 2 votes down. How cool is that? Let's change them back to what they were, 0 and 0. And now with all of this working, the last thing to do is actually making this so that we can vote on our smart contract using these 2 buttons, and that triggering our MetaMask pop-up to make the votes, and then automatically our Moralis database will update the new votes and our React app will update the votes on the screen as well. How cool is that? So let's go ahead and execute our smart contracts in our React app next. Right, so you can open your repository again and go to your coin.js component. This is where we'll build our executing smart contract functionality because we'll have access to the token that we want to vote on. And then let's import from React Moralis, use Web3 execute function, and use Moralis, which we can then destruct to be able to use in our code. So we can call our Web3 execute function contract processor, and from Moralis we'll just get the is authenticated state to make sure that the users are authenticated. They can't vote if they're not authenticated, so we'll just alert them that you have to connect your wallet to be able to authenticate. But moving forward, we can just go ahead and create our asynchronous function called vote. And all we have to take in as a parameter is if we vote up or down, and then put our smart contract functionality in here. So for our contract processor to be able to handle our request, we have to provide a few options, which are the contract address, the function name, the ABI again of the function call we're looking at, and then the parameters that this function takes. So the contract address again, simply get this all information from your Polygon scan, go to the contract code. You can get the contract address from here, add that in there. Then for our function name, we are looking to process the vote function. So we just call vote in here. And then for the ABI, go to the bottom again where you find the contract ABI, search for the vote function, which is over here, and you can copy it like so and paste it into your ABI, which has to be an array like so. So now we have our ABI. And finally, we need the parameters that we're going to pass to the vote function. So that is an object with ticker, first of all, which we can use the token from this component, and then the vote, which has to be a Boolean, which we set when calling this asynchronous function vote, and we can set that to up, down, like so. And now our options are set, and we can go ahead and use these options to make a call to our function. How we do that is simply by waiting for our contract processor to fetch parameters using the options we just set above. And if we do a successful success, we'll console log vote successful. But if there is any error, we'll just alert the user that there was an error. For example, if you've already voted on a token, you should get an error that you've already voted on a token. Now, that is how simple it is to run smart contract functions with Moralis on a React app. The last thing we want to do is just make sure that in our buttons over here, rather than setting the price manually, we can check if the user is authenticated, if they're authenticated, and we can run our asynchronous vote function with true if we press the up button, and otherwise we'll alert the user that you have to authenticate to vote. The same thing we can do over here with our down button. Rather than setting our percentage manually, we can call the vote function, but with false this time because we're voting down if we are authenticated, but otherwise we'll alert the user that you need to authenticate to vote. And if we've done everything correctly, this should be the complete build. How cool is that? Save that. Let's go to our React app over here, open it up full screen for you guys. And now is the moment of truth, testing it out. Right now, so here on our page, if we press the info buttons, they are working. We are getting the price and the description of the token. But now if we press up or down, it should run our function, but we get an alert first that authenticate to vote. Only people who have authenticated can vote. So we can use our connect wallet button, use MetaMask to authenticate. Let's use our account 3, connect, sign. And now 0x4c has connected to this Dapp. You remember that we already voted for ETH, so we shouldn't be able to vote for ETH, but we should be able to vote for BTC. So now if we go ahead and vote for down, MetaMask pops up. We have the ability to call the vote function in our smart contract. We confirm. And boom, our Bitcoin sentiment has dropped by half because now we have 2 votes, one who voted up and one who voted down. If we check out our MetaMask, our vote just went through. How cool is that? We can even check our database. So here we have the vote class. If we refresh, we just made a down vote and it was for Bitcoin and our voter was 0x4C. So everything is working beautifully. Now let's try and vote for ETH. Execution reverted. You have already voted for this coin, so it doesn't allow us to vote for coins twice, making this a very good app. Every wallet has only 1 vote and can't be skewed by one malicious voter. But let's go ahead and try and change our account. So connecting wallet, MetaMask. Let's do account 2 here, sign. So now 0x5D is going to vote, and let's vote for Bitcoin again. Let's vote down. We get another pop-up, vote, we confirm. And look at that, our voting sentiment is now 33% because we have 2 votes down and 1 vote up, and our database is already updated. 2 votes down, latest voter 0x5D, and we voted on Bitcoin. This user can vote on Ethereum as well, so let's vote up on Ethereum. Go and confirm. And automatically our Ethereum is bumped up to 67. We have 2 votes up and 1 vote down. How cool is that? You've completed the whole build. Let's recap of what we've done. We've created our own smart contract using Solidity and compiling it, deploying it, and verifying it using Hardhat. Then you created this beautiful React app, and then you've used Moralis to integrate your React app and smart contract together to be able to vote on your smart contract. But not only vote, but also read what's happening on the smart contract and display the information in your React app. So now you've created your first Dapp. How cool is that? You can go ahead and build this even further. And big shout out to Bobble's website as well, which this Dapp was based on. I hope you really enjoyed this build. Be sure to post your results on Discord and Twitter, and our community engineering teams will hook you up with a cool NFT after you finish this. I really hope this encourages your Dapp development journey and you go ahead and build Moralis projects in the future as well. Thank you, and I'll see you next time.